right, so here is chapter 2 of the notes. Yep, so we are continuing on with the factors and facts unit. So this one we're going to deal with functions. So I'm going to split this chapter into two parts because I feel like both pages deal with a fair amount of content. So we're just going to look at this page for today, and the next class I will deal with the next one. So we need to look at functions, and just a reminder what functions are. So you've seen these before. You've seen stuff like y equals mx plus b. This is one type of function that we're going to deal with. And basically a function is you have an input, you have an output. So your input is going to be the x, output's going to be the y. And we need to be able to distinguish what is a function and what is not a function. So one we've got in this is what we call the vertical line test. And the vertical line test is what you're going to do and try and figure out if something like this is going to be, if it's going to be a function or not. And I don't have a ruler. Shame on me, Mr. Brandon. But I have a card here. So what you're going to do with something like this, you should have rulers, kids. So what you should do is you're going to make a bunch of vertical lines with something like this. So you can go through vertical line, vertical line, vertical line, keep going like this. Okay, and if at any point when you make a vertical line like this, if you have one of the vertical lines you made touch the function more than once, it is not a function. So something like this one's a function. Because I don't touch it more than once. I should review this as well, probably. Just a reminder, this is your x-axis, this is your y-axis, and each of these boxes will represent one unit unless you're told otherwise. So just as a clarification, just as a reminder, that's what you're dealing with. So if we try this one, I'm not going to use the ruler this time, but on a test or something, you should be using a ruler. If you do vertical lines here, notice this vertical line touches twice. So because they touch twice, this is not a function. So you can go through and see this. I don't even need to draw the vertical lines for each of these. So this one's not, is this one a function? Yes. Mixing up my tenses. No, yes. So pretty straightforward with that. Let's look at the next part here. So inequalities. So we need to remember what an inequality is just for the sake of domain and range. So you've probably seen domain and range before, but I briefly want to remind you what inequalities are. So with an inequality, we can see basically what's going on with this on a number line. That's why you reviewed number lines, so that you can actually figure this out. So let's make a number line here, 0, positive 2, positive 4, negative 2, negative 4. So for this one, I've got that x is less than and equal to 2. So at 2, I'm going to make a closed circle because it's equal to. And since it is less than 2, we make an arrow going to the left. So anything that is to the left and including 2, this is going to be included in this. So 1, 0, negative 1, negative 2, all in that would satisfy x is less than negative 2. Let's look at this one. So x is greater than negative 3. So if we make our number line here, let's go 0, negative 2, negative 4, positive 2, positive 4, as such. So here we've got, let's look at negative 3, that's at this point. And in here, it is not equal to, it's just greater than. So instead of a closed circle, we make an open circle. And greater is moving to the right, like this. Pretty straightforward. The last one you can deal with here is x is equal to, or is not equal to, sorry, negative 2. Pick the number, 0, negative 2, positive 2. Oop, this one, not this one. X is not equal to it. So I'm going to have an open circle here because I cannot equal -2. And it can be any number to the left of this. It can be any number to the right of this. It just can't equal -2. So I'm going to put arrows on both sides like this to indicate everything except -2 fits this situation. So like I said, this is important because it's going to help us when we are dealing with domain and range. So let's look at what the domain and range of each of these graphs looks like. There's going to be two different notations I'm going to do it with this. I'm going to do one with the closed and open interval and one that's a little bit more common. When I ask for the answers in this on a test, I don't care which version you can use either one. However, you will need to be able to recognize both, because once you get higher up, you're going to see both types of notations and they expect you to know both of them. So it's good just to recognize both. You don't necessarily have to be able to do both specifically for the test. So let's look at this. So this function here goes like this. So we need to look at domain. We need to look at range. Remember, domain is X, range is Y. If you struggle with remembering this, how I always do it is I think D comes in the alphabet before R, same as X comes in the alphabet before Y. So that's how I remember it. Pretty straightforward if you remember it like this. So for the domain is what X values do I have in here? Please do not make the mistake of saying, well, it starts here and it ends here. This is not true. The arrows mean something. It means that it continues on forever and ever. So if I look at this function, this goes down and out forever this way. This goes down and out forever this way. So my domain is X is a real number. Basically, this terminology, this curved E, means X is an element of a real number, meaning X is a real number. Any number that's real works, as opposed to imaginary numbers, which you will not get into until university. So you just need to remember, if it can be anything in this graph, it's a real number. Looking at Y, the highest value of Y I have is up here. So this is at 1, 2, 3, 4, 5. There's nothing above 5. So Y has to be less than or equal to 5. And that is my range with this. Sometimes you'll see this written out saying Y is less than or equal to 5, and Y is also a real number. I'm not going to expect that because it's a little bit confusing for you guys. So I'm not going to put this every time. We're just going to assume it, at least for now. Okay, let's do this one. So domain, we've got X is going to be greater than or equal to, if we look at this, this is -1, -2, -3, -4. So X is greater than -4. And for my range, this time the Y is any real numbers. It goes up forever, it goes down forever. For this one, I'm just going to start doing this quick now, just so I don't spend too much time on this. What we've got with this one is we've got the X values. I go from -1, 2, 3, 4 up to 1, 2, 3, 3.5. So -4, X is bigger than or equal to -4, and smaller than or equal to. This graph is a little bit off. I'll make sure on the test it's bezupped where it should be, but this should be at 4. The circle's a little bit shifted, but it should be an even one there. Don't worry, I'll make sure on the actual graphs that you get, it'll be very straightforward. And then for the Y, we start down here at -3 and go up to 1, 2, 3, 4. So Y is from -3 to +4, and so on and so forth. So you can give the last one a try. I'm not going to do it for the sake of time, so the videos aren't too long. I want to get into these last few examples. So now we want to look at Oh, I totally messed this up. This is not open and closed intervals. All of this should be up here. This is what happens when you do pens. And I'm not going to redo this. You are going to see this raw, unedited, full of mistakes. And that's totally okay. So these should be here. I messed that up. I'm sorry. If you started writing in here, maybe I'll write a note that you should switch it beforehand so you don't mess up your notes. If I can figure out how to do that. I should be able to. I can figure it out. I'll do that. So the open and close bracket. I really like this notation. It's quick, it's easy. You don't have to deal with greater than or less than. Basically how this works is a closed bracket, a curved bracket is like a less than or a greater than that does not have a, does not include the number. And a square bracket means it also includes the number. So it's a greater than and equal to. So dealing with A, we can rewrite this. So domain range. Domain is all real numbers. So it goes from negative infinity all the way to positive infinity. And we use curved brackets because it never actually equals infinity. Y is less than or equal to 5. So it goes from negative infinity all the way up to 5. And it includes 5, so I do a square bracket. So you need to be sure that you have that. Let's look at the other graph. So we said x is greater than or equal to -4. So domain, I start off at -4. It includes that value and goes all the way up to positive infinity. And y is all real numbers, so this just goes from negative infinity up to positive infinity, and so forth. Next one here, domain, range. I go from -4 to +4, and my range for the y, I go from -3 to +4. Again, all those are closed when they include the number in there. Again, sorry about that mix-up of the lines. I'll make sure to do it properly down below. Let's go through this one. So we need to figure out which of these are functions and which of these are not functions. So I'm just going to put checks and x's. Is this a function? Absolutely. That doesn't touch more than once. This one, yep. This one, yep. And this one, definitely not. It's a vertical line, so therefore, if I do a vertical line here, it touches infinite number of times, so no. This one is not a function. Looking at domain and range, using the proper notations this time. So the first one I taught you is this one. The closed brackets are going to be this one. So here, notice we've got some open dots and closed dots. Open means it does not include that point. Closed means it does include that point. So I'm going to stop putting domain, the D and the R. You should know if it's domain, it's X. If it's range, it's Y. So looking at this one, I go from -2 here, and it's included, so it's X is greater than or equal to. Over here, which is 1, 2, 3, 4, 5. We'll say that's on the 5. And it does not equal 5, so it is not equal to here. It's just x is less than 5. Looking at my y values, so I go from, don't start with 0 and go to negative number. You always need the smaller number down here on the left-hand side. So I go from -1, -2, -3, -4, -5. I go from -5, not including, so just less than, up to 0, which is including. So it looks like this. If I wanted to write this in bracket notation, so because this is less than or equal to, curved bracket, -2, and not equal to, so curved bracket. Same thing here, not equal to, so curved bracket, -5, 0, close bracket like this. Again, whichever you prefer, stick with that. I like this one. This one's nice and neat. You just need to remember your brackets, but this one's good. If you use that one, that's totally fine. Let's try this one. So this one is a little bit tricky for the y's. For the x's, it's pretty straightforward. So I go from -2, it's an open bracket, so not equal to, and then where does it go to? Well, this has an arrow that points up and to the right forever, so this goes to infinity. It keeps going. So I can write it like this. You could, if you so desire, you could just write x is greater than -2. That works as well. Instead of doing this also as less than infinity, both would be the same. I'm fine with either of those. For the y, this is tricky. I have an open circle here, but notice on the other side of this parabola, I'm going to touch y equals -1. So even though here it's not included, it's included on this side. So that open circle has no distinction in here. I just have that y is greater than or equal to -1, 2, 3, 4, 5, 6. Like that. And if we want to do a bracket notation, open bracket that's curved up to infinity, which is also curved. And then y is greater than or equal to -6 because it's equal to, we've got a square bracket all the way up to infinity. Something like this. Yes, I'm going to keep doing these because I think these ones are important. So with this one, what we've got is, if you're okay with this, like I'm fine if you stop the video and if you just move on. I'm not expecting you to do the whole thing, just make sure you understand the concept. I'm doing more examples for those who want to understand it. So here I've got an open circle. So this one, actually doing it in this way, is actually pretty easy. I just write y is not equal to 2. Or sorry, x is not equal to 2. It's equal to every other number except this one. So we just keep it as such. And y is going to be greater than -3, but not equal to. In bracket notation, this one is easy in this notation, but in the brackets it's a little bit trickier. So you would do, I go from -infinity all the way up to 2, not including 2, and then I would have from 2 all the way up to infinity. So you're just having to repeat this, but that's totally fine. And then for y greater than -3, got open bracket, -3, infinity, close bracket. Last one, this little tricky one, x is only equal to -3. That's it. For y is any real number because it goes up forever and ever and down forever and ever. For the bracket notation, I'm not 100% sure. I actually have to look this up. I'll try and figure it out for class. It's either just this or it's this. I don't remember. I would need to look that up. So this, I'm not quite sure. Let me look that up, and I will try and tell you in class. Oops. Sorry, you can't see that. So it's either this or this. I'll have to tell you in class. But for this one, for the y, -infinity all the way up to infinity for the y. All right, so that one's a little bit long, but that's okay. Again, if there's a section that you're like, oh, I totally understand this function, not function, like I did all the way up here. If you want to skip a little bit and go to the part that doesn't make sense, that's fine. I'm included all the examples with this one because this one's a little trickier. But that is what I'm going to do for this class, and I will see you in class where you can ask all the questions you want.